theorem, which states that if a squared plus b squared equal c squared, then we do have a right triangle. So the most important thing when you look at the three side lengths that are given is that you make sure to take the largest number they give you and label that as C. And A and B are the interchangeable side lengths. So once you substitute the numbers given, we can substitute the 3 for A, the 4 for B, and set that equal to 5 squared. And once we go ahead and simplify that, we'll get 9 plus 16 equals 25. And when you add 9 and 16, you get 25. And then you see that 25 does equal 25. So in this case, we do have a right triangle. And so that's what you'll want to do with the rest of these examples. Once again, making sure to label the longest length as C. These ones are in not smallest to greatest, so check to make sure that you do that. Going into what we learned this past week on transformations, we're being asked to distinguish which type of transformation is happening. So just to remind everybody, the triangles that are given without any markings, just the letters, this will be labeled as our pre-image. And once it is transformed, it will be labeled simply image. So I'm going to trace over this pre-image to make sure to see which type of transformation is happening. So from here, if it were to be a translation, we would be able to take the shape and move it left or down or right, and we would be able to get to the new image without flipping its orientation. So in this case, we know it can't be a translation. In order for it to be a reflection, it would be taking this shape and having a mirror image over one of the axes, either the X or the Y. And in this case, it would be taking the Y-axis and folding it in half, and that would not result in a reflection. So a rotation is the only other option we are left with, since a dilation would result in a smaller or a larger image. So this one would be a rotation. And so when you use patty paper, you'll be able to trace and find which type of degree it's being rotated about the origin. On this one here, we have what rule describes this transformation. So again, making sure we label our pre-image and our image. And I'm going to go ahead and trace my shape again to see if we can see what type of transformation is taking place. So if I were to be translating this one, it would result in the new image just by sliding it, which is not the case. So this one looks like it is going to be a reflection. So when we reflect over the X or Y axis, the opposite X or Y coordinate is going to be changing its sign. So depending on which axis the shape is being reflected over, that will be the indicated sign change, whether it's on the X with a negative sign or the Y. So determine that by looking at which axis this shape is being reflected over. On this question, it says quadrilateral A, B, C, D. Translate 3 to the left and 4 up to form A prime, B prime, C prime, and D prime. What are the coordinates for the new image? So these markings, remember, these mean prime, which is an indicator of the image, and these regular letters would be making the pre-image. So if you have graph paper, you're more than welcome to go ahead and plot those points. What I'm going to do is rewrite the rule they give us here in number form. So they're saying our rule is taking coordinate xy and translating it 3 to the left, which would be on the x-axis, x minus 3, comma, and 4 up. So that would be taking y, and if we're moving up, it's going to be a positive. And from there, we can then take each of our coordinate pairs and translate them with the rule that I just wrote down. So I'm going to go ahead and just do A. So we went from 1 as our x, 1 as our x, and 4 as our y. So we can take the x, which says x minus 3. So 1 minus 3, which would result in -2. And then we can take the y and add 4. So 4 plus 4 would be 8. And that's a way that you can, without having to graph it, you could find the new image. So here they're asking what the length of the missing side is. So they've indicated a right triangle. And what I always like to turn the right angle into an arrow, which always points to C. I think that's the biggest issue that I've seen is mislabeling the triangle, making sure that C is our longest length. So with our formula, a squared plus b squared equals c squared, we can go ahead and substitute the numbers that they give us. And remember, a and b are interchangeable, so it wouldn't really matter which letter I substituted 7 for. So I'm going to just substitute it for a. So 7 squared plus b squared equals 9 squared. And then as I simplify that, I will get 49 plus b squared equals 81. And then from there, I can go ahead and subtract 49 from both sides. And I will be left with b squared equals 32. And then making sure that we take the square root of both sides before we finish our problem. So this one is asking for what type of transformation. They're not asking for a rule, they're asking for a type. So we have the 4 different types that we've learned about: translations, reflections, rotations, and dilations. So from those, knowing that translations are a slide, reflections are a mirror, rotations are a rotation. I don't know a better word to describe that one. And then dilations are those that will be changing size. So here it says, which of the following rules could form a reflection? So there are rules for each of our different types of transformations. So they're all going to look a little bit alike. We have them all starting with our coordinate pair on the left. We have our x and our y. And so then from there, they're telling you what is happening to each of those coordinates. So in this one, they're saying that the x is moving right 4 and down 2. So that would not be a reflection, because then it would be changing its location without just taking a mirror image of it. This multiplication one would be changing the size, which is not what a reflection is. And the last two could be a little bit misleading, but this third one, remembering that when you reflect over the x-axis, the y coordinate is going to change and the x coordinate is going to stay the same, whereas if you reflect over the y-axis, the x coordinate is going to change and the y will stay the same. So on this one, they're asking what rule describes this transformation. So I'm going to go ahead and label my two triangles. This one will be our pre-image, and then the one that indicates our image will have those prime markings on the shape. So when I take an outline of this shape, if I were to be able to slide this into the proper location, then I would know that this could be a translation, which is a slide, and that was what I see here. So now I just need to figure out how much it moved, since translations can only happen, or can't move diagonally. Can't spell that. We have to make sure we're moving, we're counting from each letter to its prime. So from here, I can go K, and I can see this is moving 1, 2, 3, 4. It's moving left 4, and then we're going to move up 2. And noticing that this is the same for each. From L to L prime, it's going to be the same. It's 1, 2, 3, 4 to the left, and 2 up. So this rule applies to each of the individual letters. So remembering that left is for negative and up is positive, and this is for the X and this is for the Y. Alright, there's that page, and we only have one more day of homework since we have our test this week. We're going to fall back into our lovely interest. So in this case, they're asking for simple interest, which is our formula I equals PRT. So what they're giving us here is they're not giving us our interest, but they are giving us 5,000 for our principal being multiplied by our rate of 0.05, which is this number divided by 100. And we're going to have to take this 60 months, the time has to be in years. So you're going to have to take that 60 and divide it by 12. And so from there, we can simplify that to 5,000 times 0.05 times 5. So remembering that this I is the I here, so this is for interest. So this A is for total amount. So for simple interest, you simply add to get your total. This is not saying to solve for the compound interest. All right, what type of transformation? So they're asking for a type. So meaning of the 4 different types of transformations. Remembering, is it a slide? Is it a mirror? Is it a rotation? Or is it a dilation? What rule? So on the last one it asked for the type, and this one is asking for the rule. So remembering that's taking our x and y coordinate and transforming the x and the y accordingly. So if it's a reflection, it's going to take the axis that it's being reflected over and the opposite coordinate will change. So I'm going to write down just this last, here's our x and y, 1, 2, 3, 4, -4, 1, 2, 3, 4, +4. I'm going to write d prime, which is 1, 2, 3, 4, +4. So looking at what changed between here and here with the x and y, that could help you determine the rule for the transformation. And the last one says, what type of transformation does each rule cause? So remembering how to determine the rule by looking I think that's my biggest advice, is to look at the pre-image x and y and notice what happens to the x and y in the image to determine if it's moving locations but not changing orientation, or if it's being reflected, or if it's being rotated. Hopefully that is helpful, and hope you do good on your test.